Got my X and Y squareness and dimensions dialed in, but there's apparently some sort of a problem affecting my Z squareness. So after noticing that my test mounts weren't square in Z, I printed this test cylinder in vase mode. It's 20 millimeters diameter, 200 millimeters high. I printed it off center just to exaggerate any sort of effect that there might be. This actually looks pretty good to me. Not perfect in Z, but pretty good. And this definitely looks better than what I'm seeing on the, on the mount. So, yeah, for comparison, that's what I'm seeing on the mount. And keep in mind, that's two of them, so it's doubled. But that's still steeper than what I'm seeing on this test print over here. So, my current working theory is that this is not due to the printer, it's due to shrinkage in the material as it cools. It's tapered in all the way up till the top. So I'm thinking it has to do with this triangular gusset that I put in here. So there's more material on the bottom, therefore more shrinkage, and less material and shrinkage as you get to the top. All right, here's my redesign. Got rid of that triangular brace there. And here's the bearing mount at the front. And I left out this top portion so that I could print in this orientation without any support and still have a good bearing fit that didn't need any cleanup. And this seems to have done the trick. This bearing's only going to be seeing forces in compression going down, so it's adequately supported. I don't have one in there now, but the timing pulley will go right in there. So this came out much more square than my previous in Z. So I didn't change anything about the printer. That was all just design. Now I'm wondering if if the belt placement on my original mounts is due to the same effect. And you can definitely see ringing around some of these features. Like you can see the echo of this shape in the material over there to the right. That's definitely ringing in the system when it's making fast direction changes, so I could definitely use some more tension in the belts. I was unable to just flip this timing pulley around because I wouldn't have enough flat length on the D shaft. So if I just flipped that pulley around, where the set screws would be perfectly round. So there wouldn't even be one set screw sitting on a flat part of the shaft. So I left it in this orientation, and I just moved this vertical support that way, 3 millimeters. All right, first print with the revised stepper motor mounts, and this is a revised rear counterweight pulley. I needed some additional clearance. So up here on the revised mount, you can see that the belt isn't tracking to one side or the other on the timing pulley, which is great. This is exactly what I wanted. So this should be as square as I can possibly make it to this tower axis. So you can see the end of the stepper shaft is riding in a bearing. So this should provide more uniform tension on the fibers in the belt. So I'm still running the second set of open builds GT2 belts, and these are a little bit thinner in both dimensions than the Gates belts. So these are about 5 millimeters wide. So I'll run these until they fail, and if they fail, I'll switch over to Gates GT2 6 millimeter belts, which are a little bit wider and a little bit thicker, and hopefully a little bit stronger. But yeah, the part I'm printing right now is a revised rear counterweight pulley, because the original one wouldn't clear the stepper mount.